Okay, so let's look at a question worth 6 marks and see how we can get the full 6 marks. Okay, so the question asks the following. So you've got to calculate the pH of a buffer solution when 60 centimeters cubed of 0.2 moles per decimeters cubed generic acid, HA, is mixed with 40 centimeters cubed of 0.01 moles per decimeters cubed hydroxide. And the other bit of information we're given is at this particular temperature the Ka of the HA or the acid is equal to 1.8 times 10 to the negative 5 moles per decimeters cubed. So how do we get these full marks? Well, the first thing we're looking at is we break down the question and look at some numbers. Okay, so we're given the volume and the concentration of the weak acid, and also the volume and concentration of the hydroxide, and also the Ka. So let's write that down. Okay, so the concentration of the acid is initially 0.2 moles per decimeters cubed, and the volume of the weak acid is going to be equal to 0.06 decimeters cubed. Noticing, of course, that we have changed it into decimeters cubed. And the concentration, at least initially, of the hydroxide will equal 0.01 molar decimeters cubed, and the volume is going to be equal to 0.04 decimeters cubed. And the Ka, of course, is already given. So then we've got to look at what is actually happening in this reaction. Okay, so basically the weak acid is reacting with the hydroxide to give the conjugate base plus a little bit of water. I'm not sure what happened there, a bit of water. Okay, and also naturally in the water, the weak acid is dissociating to give the corresponding conjugate base and a proton. So there's 2 reactions happening, and that is your first mark. Okay, so the next thing we're going to do is work out the number of moles of alkali which are being taken, and that, using this second equation, will work out the amount of A minus that's being formed. Okay, so number of moles taken will equal the amount of A minus, number of moles of A minus being formed, which will equal 0.1 times 0.0, okay, just look at these numbers here, 0.04, 0.04, which equals 0.004 mole. Okay, so that's the amount of A minus conjugate base that's now being formed in that first equation. Then we've also got to work out the number of moles of the weak acid being taken. Okay, because as the reaction goes, it's reacting with the hydroxide, the weak acid, to form more of this conjugate base. And that's going to be equaling the concentration of the acid, okay, times the concentration, or the volume of the free acid, which is going to be 0.012 molar. Okay. Therefore, the amount of amount, which of course is your number of moles of the HA or acid left, is going to be equaling the difference between these two numbers, 0.012 minus 0.0040, which equals 0.008. That's a bit messy. 0.08 moles of HA left. Of course, we don't want number of moles. We actually want the concentrations now. Okay, so that's 1 mark calculated there, so you've got 2 marks now, and therefore the concentration of the weak acid, the concentration of the weak acid is going to be equaling 0.008 divided by 0.1. Okay, so it's 0.1 because the combined volume of the solution is 40 plus 60, which is 0.1 decimeters cubed. Okay, so that will equal 0.08 moles per decimeter cubed, and that's what the weak acid left is, and that the concentration of the conjugate base, make that a little bit neater, is going to be equaling 0.004 divided by 0.1, which equals 0.040 moles per decimeters cubed. Okay, so the amount of acid, a weak acid, is decreasing in terms of concentration, and the amount of the conjugate base is of course increasing, and that's going to be worth 1 mark. So we're halfway there, we've got 3 marks. Okay, so the next mark is you've got to show the examiner you understand what the equilibrium constant term is. Okay, so Ka, from our second equation here, okay, the second equation here is going to equal the concentration of the H plus, okay, concentration of the H plus times the concentration of the conjugate base divided by the concentration of your weak acid. Okay, so that's going to be another mark, so you have 4 marks in. Okay, and you can then plug the numbers in. Okay, so we know, and we know this equals 1.8 times 10 to the negative 5 moles per decimeter cubed. Okay, so we're nearly there. Okay, so then we have to show the rearrangement of the equation. Okay, so H plus therefore equals the Ka times the concentration of the weak acid divided by the concentration of the A minus. Okay, that's 1 mark. And we just plug those numbers in. 1.8 times 10 to the negative 5 times 0.080 divided by 0.040. Okay, just plugging those numbers in, which you're very capable of doing, which equals 3.6 times 10 to the negative 5 moles per decimeters cubed. Okay, great. And then the final mark is going to be P pH equals the negative log base 10 of the concentration of the H plus, which will equal negative log base 10 of 3.6 times 10 to the negative 5 moles per decimeters cubed, which will then give the answer we want, which is 4.44. There we go, and there is your final mark. So 1, 2, 3, 4, 5, 6 marks, easily achieved, and that's how you get a full 6 marks in such questions. No.